Good evening. Thank you, President Feller, for allowing me to introduce the distinguished speaker this evening who was invited here as part of your distinguished presidential speaker series. And thank you all for coming, especially I know several of you from Chicago and other distant places. This is a special evening indeed. It has all the underpinnings and sense of urgency to change our lives for the better. My name is Mac McNaught, class of 1976. It is indeed an honor to introduce Professor Douglas Tallamy, one of our nation's foremost ecologists, who has taken his research, his measurements, if you will, well beyond academia and into the public realm. Doug Tallamy comes to us from the University of Delaware, where he has taught entomology and ecology for the past 40 years. It'd help if I had the mic up here. His research focuses on the impact of non-native, if you will, sometimes invasive, terribly invasive plants, but not always, on our ecosystem. Professor Tallamy's research has led him to write Bringing Nature Home, published in 2007, Nature's Best Hope, a New York Times bestseller, published in 2019, and most recently, The Nature of Oaks. The impact of our speaker's research, writing, and call to action reaches far and wide, even to South Alabama, where the South Alabama Land Trust now includes the following quote in all of its mailings: "The conservation of Earth's resources, including its living biological systems, must become part of the everyday culture of us all, worldwide." Douglas W. Tallamy. Please extend a warm Wabash welcome to Professor Tallamy. Or Doug.
Brandon, just push. That's why he's the president. Okay. Okay, thank you. Thank you very much. I don't remember saying that, but it sounded good. So whatever that quote was. Brandon, is it possible to lower the lights on the stage a little bit? No, it's not possible. Okay. All right. Well, that looks better when it's darker, but does anybody know what that caterpillar is? You think about it during the talk. I'm going to ask again at the end. But all right, that's what we're going to talk about, Nature's Best Hope. My idea of what Nature's Best Hope is, and I'll give you a spoiler, you are Nature's Best Hope. So I'm going to tell you about why I think you're Nature's Best Hope. But before I do that, let's talk about what E.O. Wilson's idea of Nature's Best Hope was. E.O. Wilson, of course, I'm going to call him our most famous scientist, at least in the biological sciences. He died the day after Christmas 2 years ago, not this year. And it was a terrible loss to the world of conservation and entomology and myrmecology and sociobiology and all the other things that he did. But one of the things that was consistent throughout his very long career was his effort to save life on Earth. He loved life, he loved biodiversity, and that's not why he wanted to save it. He knew it was essential to our own survivorship. So he wrote this book in 2016, Half Earth, Our Planet's Fight for Life. And his message, he had one simple message in that book. If we're going to save life anywhere on planet Earth, we have to save functioning ecosystems. We have to save nature on at least half of the planet. And he spent most of the book talking about the science that supports that very bold statement. And then he ended the book. He did not spend a lot of time telling us how we were going to save life on half of planet Earth. And so, of course, a lot of people are wondering how this could be possible. Conservation biologists think it's a great idea. We just put half of the planet aside and all of our extinctions will disappear. It'll be wonderful. But half of planet Earth, terrestrial Earth, is already in some form of agriculture. And we've got 8 billion people in the other half, along with all of our houses and railroads and detritus, and we don't have a third half to put aside for nature. So how are we going to do this? That's basically what I want to talk about tonight. I do think we can realize EO's dream, but we need a new approach to conservation to do that. But before we talk about that approach, let's talk about what happened in the East Coast in 2019. We had a very large oak mast, where members of the red oak group got together and decided to make their acorns at the same time. And this is what it looked like in a lot of places. Well, I'm easily entertained, so I just stared at one of those acorns. And I was rewarded, because the insect started to chew its way out of the acorn. First chewed a little hole for its head, then it forced its head through there, then it forced its entire body through that hole. Didn't take long. It was a tight squeeze. And when it plopped down, it was a very dangerous time for that insect larva, because a lot of things like to eat it. So it gets to safety by wiggling and squirming beneath the soil surface in about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber, converts itself to a pupa, and then surprisingly stays underground in that chamber as a pupa for 2 years. After 2 years, comes out as an acorn weevil. That's what an acorn weevil looks like. A lot of people think weevils have big noses, because it looks like they do. That's actually an extension of the head capsule, and the mouth parts are way down there at the end of that extension. They take those mouth parts and chew a hole into the center of the acorn, turn around and lay an egg in it, and that's how the larva gets into the acorn. Why do they spend 2 years underground? Why don't they come out the next year the way most insects would? Well, it takes red oak acorns 18 months to complete their development. So if they came out the next year, there wouldn't be enough acorns for them. Of course, after they leave the acorn, it leaves a hole, kind of like a true vacuum. And you know that nature abhors a vacuum. In this case, she's filled it with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils after they'd left the acorn. And if scouts find a new hole in a new acorn, they get all excited because their old acorn is falling apart. So they tell everybody it's time to move. They grab the larvae, they grab the eggs, they move the entire colony into the new acorn. That takes about 30 minutes. Then they post a guard there, make sure nobody else comes into that acorn. And that's where they will live for the next 2 years, until that acorn falls apart. What's my point with this little story? Well, that's just one of literally millions of very specialized interactions, largely between animals and plants, that comprise the bulk of nature. This is another one, the relationship between jays and oaks, jays and acorns. Jays are the primary disperser of oak acorns. They will take an acorn and they'll fly up to a mile from the parent tree. And I actually read the other day, no, it's 1.5 miles. Long way. They fly a long way from the parent tree. And then they tap that acorn beneath the soil surface. And the object is they're going to go back in the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where one is. So for every 4 acorns they bury, they've actually planted 3 oak trees. The specialized relationship between pileated woodpeckers and carpenter ants. That's what they rear their young on, carpenter ants. So you won't have pileated woodpeckers unless you have a lot of carpenter ants, and you won't have a lot of carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have that plant, Facilia. That is the only pollen that bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We have about 4,000 species of native bees, and over 1/3 of them can only reproduce on the pollen of particular plants. So if you don't have those plants, that's more than 1,000 bees that will not be around. You won't have the Baltimore checker spot unless you have white turtlehead. I could talk all night, all week, all year about nature's specialized relationships. The point I want to make, though, is that many of these relationships, unfortunately, most of them these days, are in trouble. They're on the ropes. Nature itself is on the ropes, largely because we did not take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, "Leave it as it is." And with those 5 words, he started the process of creating the Grand Canyon National Park. Well, we didn't leave most of the country as it was. There's only about 5% of the lower 48 states that's anything close to its original pristine ecological condition, and those are largely mountaintops. And that's because we have logged the country repeatedly. We have tilled it, we have drained it, we have grazed it. It's 770 million acres of rangeland in this country. That's 4.5 times the size of Texas, dedicated to cattle. And of course, we've paved it or otherwise developed it. We have straightened our rivers and dammed them. You can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we've carved up those natural areas into tiny remnants of their former selves. And each one of those remnants is too small and too isolated to support the amount of nature that we humans need them to support, because that is what keeps us alive on planet Earth. So you might wonder why we've done this. I wonder why we've done this, and I don't know. But I suspect that we thought that Earth, our nest, was so large we could foul it forever and there wouldn't be any consequences. But of course, we're wrong about that, and that's why we're seeing some pretty scary headlines these days, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Followed by this one, North America's lost 3 billion breeding birds in the last 50 years. That's a third of our North American bird population already gone. And now the UN says, well, we're going to lose 1 million species to extinction, probably in the next 20 years. And they said that 2 years ago, so now it's the next 18 years. Makes a nice headline, but it is not an option, folks. These are the species that keep us alive. So we have to make sure that doesn't happen. I could go on talking about the pox that we humans have delivered upon the environment, thus upon all of our houses, but that is not what this talk is about. This talk is about a cure for that pox. It's a cure that'll take small efforts from lots of people like you and me, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Well, back to E.O. Wilson. He told us what it would mean if Earth lost its insects, and he did it way back in 1987 with this paper, The Little Things That Run the World. And again, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support most of our animals, our amphibians, our reptiles, our birds, our mammals, those food webs would collapse and those animals would all disappear. The biosphere, the living portion of the Earth, would rot because we would have lost insect decomposers that rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans wouldn't survive any of those drastic changes. There is some good news, and that is that none of that has to happen. We can save our insects, we can save our birds, we can save the nature that supports us, but we're going to have to change the way we landscape in order to do that. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support that ecosystems provide. We call them ecosystem services. Here are just a few things that plants do that we depend on every day, like produce oxygen, pretty important, cleaner water, slow its journey to the sea or it becomes too salty to use. Carbon capture, enormously important today. Not only are plants pulling carbon dioxide out of the atmosphere, out of harm's way, and building their tissues out of that carbon, but they're also pumping it into the ground through their root systems. Our soils are brown or black because of the carbon that plant roots have deposited there over the eons. And once it's in the soil, it's stable. It can stay there for thousands of years until the soil is disturbed. Plants are building topsoil, holding it in place, preventing floods, dampening severe weather, converting sunlight into food. If we lost our plants, we'd have to eat sunlight. That'll be an IT challenge. What are animals doing for plants? Lots of things, but these are important ones. They're providing pest control services, pollinating nearly 90% of the flowering plants that are out there, dispersing plant seeds. So designing landscapes like that destroy the production of ecosystem services is just not a good idea. Never was a good idea, but it's a terrible idea because of those 8 billion people that are now demanding more ecosystem services than ever before. And of course, we're taking them, but at the expense of all the other living things on the planet. That's not sustainable. Now, we do have parks and we do have preserves, and they're doing the best they can, but we are in the 6th great extinction event that the planet has ever experienced, which means it's not good enough. So now we have to start practicing conservation outside of parks and preserves, on landscapes just like that. Now, there have been visionaries through the ages who have recognized that we humans needed to work on our relationship with planet Earth, and Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. And one of the things he said is that the oldest task in human history is to live in a piece of land without spoiling it. Now, there certainly have been indigenous groups that have been able to do that for long periods, But our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another area, doing the same thing. Not sustainable behavior. But Otto Leopold had a lot of faith in humans. He believed that we were capable of developing what he called a land ethic. He knew we had to use the land. We had to farm and lumber and graze and mine and do all of those things. But he believed we could learn to do them gently enough that we did not destroy local ecosystems. That's what he called a land ethic, and he wrote about it in the Sand County Almanac. What he did not write about, though, was developing a land ethic where we actually lived. And I'm not sure why that was, but I believe that the notion that humans and nature cannot live together, we cannot coexist in the same place at the same time. That notion was so deeply embedded in the culture of Otto Leopold's day. It's still embedded in our own culture, that he might not have recognized it as an option. What I want to argue this evening is that not only is living with nature an option, it is now the only viable option that's left to us. In the past, of course, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. In other words, we've got to find ways for nature to thrive in human-dominated landscapes, not hang on by a thread, not get diminished every year, but thrive. Where should we start? Well, let's go back to private property. Most of the country is privately owned. 78% of the entire country is privately owned. 85.6% of the U.S. east of the Mississippi is privately owned. We're east of the Mississippi here, right? Privately owned. So again, if we don't practice conservation on private property, we're going to fail. And when I use the word conservation, I'm not really using it correctly the way I mean. We do want to conserve any bits of nature that are left out there, absolutely. And that has been our conservation model for the last century. But now we have to go beyond that. We've got to move into restoration. We've got to put back together again so many of the places where we have removed natural systems. And before you tell me that there's no way you're going to restore any particular place to exactly what it was in some time in the past, I know that. But we can reunite enough of those specialized interactions that I opened the talk with to create functional ecosystems again, even if it wasn't exactly what was on that particular spot, again, at some point in the past. But there are building blocks of ecosystems. Not all species contribute to ecosystem function equally. So we have to start with the building blocks, the most important species. And there's two groups that we can't do without. One is the flowering plants and the pollinators that allow those plants to reproduce. They are capturing energy from the sun and through photosynthesis turning it into food, and that is the food that supports just about all the animal life on the planet. So now the energy from the sun is stored pretty much in plant leaves. If you don't get that to animals, you don't have any animals. And if you don't have any animals, you don't have a functioning ecosystem. Well, it turns out that most vertebrates don't eat plants directly. Most vertebrates eat invertebrates that ate plants. Most of those invertebrates are insects, and not just any insect. Most of the invertebrates that are transferring energy from plants to animals are caterpillars. Caterpillars are transferring more energy from plants to animals than any other type of plant eater. So if we design landscapes that don't have a lot of caterpillars in them, we eventually will have failed food webs and failed ecosystems. I'm going to use the Carolina chickadee as an example. That's the chickadee that I have at my house in southeast Pennsylvania. You probably have the black-capped chickadee here, almost the same bird doing the same thing. They're the birds that are feeders all winter long eating seeds, and we tend to think that's all they need, is seeds. Well, even in the wintertime, only 50% of their diet is seeds. The other 50% is insects and spiders, even in the wintertime. And when they're reproducing, their babies can't eat seeds at all. So they give up the seeds, they switch to invertebrates, and if they're in a healthy environment, they will rear their young exclusively on caterpillars. And they are not alone. 96% of the terrestrial birds in North America rear their young on insects, and most of those insects are caterpillars. How do I know that? There's lots of lines of evidence that suggest that, but this is a citizen science project that one of my grad students did a few years ago, Ashley Kennedy. She put out a call to bird photographers around the country and said, please take pictures of birds during the breeding season when they're carrying food to the nest. Some of you might have participated. and send those pictures to Ashley. She's going to identify the prey items that are in the beaks of the birds and reconstruct the nestling diet for as many species of birds in North America as possible. And there's a lot of bird photographers out there, so it was very successful. She got thousands of pictures. And you're looking at a summary of her results for the 20 most common bird families in North America. The green bars are the percentage of those nestling diets that were caterpillars. And in 16 out of the 20 common bird families, caterpillars dominated the diet. So again, what would happen to bird populations if we design landscapes that don't have enough caterpillars? Most of our birds would not be able to successfully reproduce. So there's something special about caterpillars. What is it? There's actually several things special about caterpillars. And one of them is that they're soft. So think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is exoskeleton. It's made of chitin. It's undigestible. And because they're soft, you can stuff the caterpillar down the throat of your offspring without fear of injuring them. And if you've ever watched a parent bird rear their young, they're pretty rough. Beaks like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're nutritious. They're very high in fat, very high in protein, low percentage of chitin, of exoskeleton compared to most other insects, particularly beetles. Beetles are not like little sausages, they're like little tanks. So much of a beetle is undigestible, and a lot of beetles have sharp edges too. And then finally, it turns out that the caterpillars are the best source of carotenoids for birds during the breeding season. Now, I mention carotenoids not because I love organic chemistry. I do like chemistry, but not that much. I mention because I'm a vertebrate, and you're vertebrate, and birds are vertebrates, and we vertebrates cannot make our own carotenoids. Only plants make carotenoids. So we have to get our carotenoids from plants. And we have to get them from plants because carotenoids are essential components of vertebrate diets. Where are the birds getting their carotenoids from? Particularly during the breeding season, from what they eat. But look, carotenoid content is not equally distributed among bird prey items. These first two bars here are types of caterpillars. They have far more carotenoids than other types of bird prey. Here are the adult caterpillars. Here are the moths and butterflies themselves. They have far fewer carotenoids because they're not eating the green leaves. That's where the carotenoids are. And here's the earthworm way down here. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. So that study and several others are suggesting that caterpillars are not optional parts of most bird diets. They are essential parts of most bird diets. So let's just say most birds need caterpillars. The next question is, how many do they need? Is one or two enough? One or two a day enough? Well, that's a good question. So let's go back to chickadees. There are a lot of data on chickadees. How many caterpillars does it take to make one nest of chickadees? One or two is not enough. One or two a day is not enough. It takes thousands, 6,000 to 9,000 caterpillars to get one clutch of the Carolina chickadee to the point where they leave the nest. And after they leave the nest, after they fledge, the parents continue to feed them caterpillars another 21 days. So you're really talking about tens of thousands of caterpillars to get one bird that's a third of an ounce through to maturity. And if you want chickadees to breed in your yard, and I would think you do because in so many places, that's all that's left is our yards, you have to have all those caterpillars in your yard because the birds are only foraging about 50 meters from the nest. They are not flying 5 miles down the road to the nearest woodlot. And if we landscape in a way that does not include all of those caterpillars, all of those insects, that's called insect decline. And it's really looking like that's one of the major causes of the bird declines that people are measuring. We went to the original data set of Rosenberg et al., that's the Smithsonian group that said we've lost 3 billion birds in the last 50 years, and divided the terrestrial bird species into two groups. The groups that require insects at some part of their life history, typically when they're breeding, and the birds that do not require insects. So things like doves and finches and crossbills, they can actually make a milk out of seeds, and they can rear their young on seeds. So look, the birds that do not require insects didn't lose any numbers at all in the last 50 years. But the birds that require insects lost on average 10 million individuals per species. It doesn't prove cause and effect, but it does suggest that there is a relationship between the amount of food that's there and the birds. If you take the bird food away, yes, you're going to lose the birds. So we need to raise the bar about what we're asking our landscapes to do. In the past, we asked them to do one thing: be pretty. All right, They're still going to be pretty, but now we have a harder job. Now we have to make them pretty and ecologically functional at the same time. And that's not going to happen unless you put caterpillars back in those landscapes. So how do we add caterpillars to landscapes? It's pretty easy. You put the plants that make the caterpillars in those landscapes. There is a catch, though, and that is that most plants don't make a lot of caterpillars. So we have to be fussy about which plants we're choosing for our landscapes if we want caterpillars in there. And we have to be fussy about it because the caterpillars themselves are fussy. And the monarch butterfly illustrates it perfectly. You can have all the Callery pear and all the burning bush and all the barberry and all the ginkgos and all the hostas and all the things we typically landscape with in your yard, and you won't make a single monarch butterfly. You're only going to make monarchs if you have milkweeds. That's called host plant specialization, and it turns out that most of the insects that eat plants are host plant specialists. Why? Because plants have made them specialized. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty-tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And if you don't believe me, in the springtime, go out and eat a plant. See if you like it. You're not going to like it. And that's why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. There is a reason it's hard to get our kids to eat their vegetables. They inherently know they're toxic. But insects do eat plants, so how do they do that? How do they get around those chemical defenses? Well, this is where the specialization comes in. 90% of the insects that eat plants can only eat particular plants. They can only eat the plants for which they have developed specialized adaptations over the eons to be able to counter all of those chemical defenses. Specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize the insect's exposure to those compounds. But it does take a long period of evolutionary history with the plant lineage for all those adaptations to fall into place. And when they do fall into place, the insect's locked into eating that particular plant. So if you take the milkweeds out of your yard and replace them with hostas, the monarch's not going to start to develop on hostas. It has two choices: fly away and find milkweeds someplace else, or starve to death. So it turns out this is actually very easy. There's three kinds of plants out there. There are plants that contribute energy to local food webs, plants that do not contribute energy to local food webs, and plants that actively detract energy from local food webs. Perhaps, probably, almost certainly, the best contributor in this country is one of the oaks. They're widely distributed. They're contributing more energy to local food webs than any other plant that we know about. A good example of a non-contributor would be a ginkgo. Ginkgo biloba from Asia. Nothing eats a ginkgo, but it's not invasive. It's just kind of sitting there. So it's not contributing any energy. We'll just say it's a non-contributor. And a great example of a detractor would be Callery pear, because not only is it not supporting local insects, it's not adding energy to food webs, but it doesn't stay where we plant it. It escapes and becomes a serious invasive, pushing out the native plants that do contribute. So again, all I'm saying is that plant choice matters. We are not going to restore functional ecosystems if we don't choose the right plants that support the food webs in those ecosystems. And I'm going to give you 3 examples of how well that works when you do choose the right plants, starting with my house right here in Oxford, Pennsylvania. This is where my wife Cindy and I moved in the year 2000. It was a farm that was broken up into 10-acre lots, a very old farm, been farmed to just about 300 years before they sold it. And the last thing they did was mow it for hay. So very little there. And our goal was to restore it. Now, this was the year 2000, before I had thought much about restoration or actually knew anything about it. But I knew I did like caterpillars, and I wanted to get caterpillars back in this property. So one of the things I wanted to do was to see if I could get the Canadian owlet to start to make a living at our house. Why did I choose Canadian owlet? Well, I looked through Dave Wagner's insects or caterpillars of eastern North America. I said, that's a pretty one. So we started with that. That's what the adult looks like, just like a leaf. I'd never seen the adult or the caterpillar before, but I did know that you're not going to have Canadian owlets unless you have their host plant, which is meadow rue, and we didn't have any meadow rue. I'm sure there was meadow rue there hundreds of years ago, but the entire area was farmed to death. Meadow rue long gone. So I got some meadow rue seeds from someplace, and I planted them, and they grew very nicely. But this was early on, and I actually had very little faith that Canadian owlets would be able to find my little patch of meadow rue. I mean, maybe they had to come from Canada. I don't know. So I didn't even go out and check my patch of meadow rue for at least 2 months. And then I was walking by for another reason. I looked over, and it was covered with Canadian owlets. They had found it right away. I'm still impressed with that. So now we have a good population of Canadian owlets and meadow rue. So we've added 2 species to the property. The restoration has begun. Same story with the goldenrod stowaway. It's actually a misnomer. That beautiful moth has nothing to do with goldenrod. It's a specialist on this plant, Biden's aristosa, ditch daisy. We didn't have any ditch daisy, but I did know where there was some ditch daisy in a power line cut about 14 miles away. So I got some seeds and I planted them at home, and they grew very nicely. They actually took over my front lawn this year. Somebody was asking me how much lawn I have. Well, at this point, none. But they're pretty. I had to wait a year for the goldenrod stowaway to find my Biden's aristosa, but they did, and now we have a good population of both of those. So now we've added 4 species to the property. I wanted to see if I get the hackberry emperor at our house, not because it's the most beautiful butterfly in the world, but because it belongs there. It's one of the species that should be there. But we didn't have any hackberry. We didn't have any celtis. That's their host plant. So I got some celtis trees. I planted them. Took 4 years for the butterfly to find my celtis, but they finally did, and now we got a good population of those. So now we've had 6 species, and that's how the restoration proceeded. I did not plant goldenrod. It came in on its own, but along with it came many of the things that require goldenrod, like the beautiful brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. Now this, surprisingly, is one that has not come, the goldenrod flower moth. I don't know why it hasn't come. That's what its caterpillars look like, but it's still part of the fun. It's anticipation. It's like waiting for the ketchup to come out of the bottle. Every year I go out and I look for those caterpillars. One of these years I'm going to find it, and that'll be a great year. I planted Virginia creeper. Yes, Virginia creeper. I hear some people don't like Virginia creeper. I just don't know why, because it is a good native plant. It's got good fall color. It's a good ground cover. It can climb our trees without girdling them, without pulling them down. It makes nutritious berries for the birds in the fall. And by nutritious, I mean they're high in fat. That's what migrating birds need, is fat. And that's what overwintering birds need, is a lot of fat. And those berries come from tiny little inconspicuous flowers in the early summer. You don't even know Virginia creeper's in bloom until you see this big cloud of native bees around it. It's a wonderful pollinator plant. Remember, when you're making a pollinator garden, you're making it for the pollinators. If it's not big and showy for you, that's okay. I planted Virginia creeper because it's the best host plant for the large sphinx moths that are a primary component of cardinal diets. Things like the Pandora sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. Wanted to see if I could get the double-toothed prominent at our house, just because it's such a cool-looking caterpillar. Looks like a stegosaurus. So even if you don't like caterpillars, you got to like this guy. It is a specialist on elm, particularly American elm. And of course, we lost our American elms to Dutch elm disease decades ago. But there are 2 American elms at the University of Delaware that did not die. And they drop a lot of seed every year. So I gathered some seed up out of the gutter, which, by the way, was free. Nobody charged me for that. Planted them. They germinate in 6 days. They grow very quickly. That was 20 years ago. Those trees are 80 feet tall now. And they did attract the double-toothed prominent, and they have not gotten sick either. So there we go. American elm. Wanted the evening primrose moth at our house because it's a pretty moth. I like beauty like anybody else. Believe it or not, we didn't have any evening primrose. So I planted that. The moths came. They spend the day with their head stuffed in the flower. Sometimes it's crowded, but it's always very cute. And I planted lots of oaks. Now, these are just examples of the plants that we put back at our house. But I want to focus on oaks for a while because they are such important plants. This is the senior moment oak. The Bedford oak in Bedford, New York. Martha Stewart land. It's enormous. People argue about whether it's 400 years old or 500 years old. And I hear people say, well, I'm not going to plant an oak because I won't live long enough to enjoy it. And if you can only enjoy your oak when it's 400 years old, you're right, you won't. But if you can enjoy what your oak contributes to your local food web, and remember, that's one of our new goals, you can enjoy it immediately. And I can say that with confidence because I planted most of my oaks as acorns. They were free too. Or 2-foot bare root whips, which cost $1.50 each. And immediately they started to rebuild the food web by calling in the moths that create the caterpillars that everything else eats. Things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, Suzuki's promolactus, the red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the orange-patched smoky wing, the white-blotched heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and literally hundreds more species have come to the oaks in my property, and they come right away. This is a pin oak. I love it how people clap for the oaks. It's great. I clap too. That's a pin oak that just popped its head above the leaves, and there's a caterpillar standing on the ground eating the leaves of that tree. First year, you don't have to wait decades or hundreds of years for your oak to start to contribute to your local food web. So that's what our property looks like, actually what it's looked like before the Bidens took over my little lawn there. But the object is to show you, we put some plants back. Not all of them. You know, I add plants when I get a chance. And by we, I mean me, the blue jays, the squirrels, the wind, you know, the seed bank. A lot of things came up from the seed bank, believe it or not. And my research over the last 20 years has shown that if you know the number of caterpillar species in your local food web, you have a very good metric of the stability and productivity of that food web, because caterpillars are they're the bread and butter in there. So 5 years ago, I started to count the number of moth species. I haven't gotten to butterflies yet, but the moth species that are making a living at my house now, I'm still at it, but I'm up to 1,199 species of moths that I've taken pictures of. You can look at my PowerPoints to prove it. Now, we've got 10 acres. Pennsylvania is 2.4 million acres. So in 240,000th of the landmass, we've got 44% of all the moths that occur in the entire state. And because so many of them are types of bird food, we've recorded 60 species of birds that have bred on our 10 acres. Not flew by, but bred. Why am I telling you this? Well, this is another headline we hear about all the time. The World Wildlife Fund says that Earth has lost 2/3 of its wildlife since 1970. It's a terrible statistic. But I'm thinking, not at our house. I'm convinced we have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody puts the plants back? We really could turn things around. So don't give up. That's the message there. But I know what you're thinking. We've got 10 acres. Most people have less land than that. Most people are living in suburban or urban areas. Will it work on smaller properties? That is a good question. So let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri, where they have 0.6 acres, 18 times less land than Cindy and I have. They're in the middle of a development. Everybody else has the big lawns. When they moved into their property, it was choked with Elmer honeysuckle, bush honeysuckle. So the first thing they did was get rid of that. Then they planted 70 species of native plants. They added a water feature that they call a bubbler. And then they sat back and started to count the birds that are using their property. And they are up to 149 bird species, including 35 warbler species. If there are any birders here, you know that that is a very good number. Just to compare it to our house, we've only recorded 8 warbler species at our house. 0.6 acres. Does it work on smaller properties? Yes, it does. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago. That is O'Hare Airport right on the other side of that wall there. Pam has 1/10 of an acre, 3 times smaller than the average lot size in North America. It's a pretty 1/10 of an acre because Pam is a native plant landscaper. She's good at it. But it's an island. It's not connected to any natural area at all. Didn't matter. She did the same thing. She got rid of her non-native plants. She put in 60 species of native plants, little water feature, and then she sat back and she says, with a glass of wine, and started counting the birds that are using her property, and she's up to 124 species, using her 1/10 of an acre, including a woodcock. There's Pam's woodcock. So if you haven't seen a woodcock lately, go to Pam's house. It's right there in Chicago. All right, there's 4 things that we need to talk about if we're going to succeed in a big way, and we need to succeed in a big way. And one of them is we've got to reduce the area we have in lawn. Latest figure I heard is about 44 million acres of lawn in this country. That's an area bigger than all of New England, dedicated to an ecological deadscape. Why do we do that? It's a status symbol. We know that. And we need places to display our Halloween decorations. But what if we cut the area of lawn in half? So what if we took areas like this and we turned them into this? This is a landscape in progress here, but I got this picture from Dan Getman. I've never met Dan Getman, but he said, look, this all used to be lawn, I'm replacing it, and here's this picture. So, well, if we did that on half the area, let's make the math simple, say it's just 40 million acres, that would give us 20 million acres that we could restore right where we live, simply by reducing the area of lawn. And if we do that at home, we can create a new national park that I am calling Homegrown National Park, and it'll be big. It'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badland National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. You add up all those parks, still less than 20 million acres. So Homegrown National Park be the biggest park in the country. What do we get when we put a park at home? We get the opportunity to interact with, to develop a personal relationship with some part of nature. All we have to do is go outside. We can do it at our own pace, our own time. Maybe all we have to do is look out the window. We can avoid crowds. You know, if you go to a real national park, 375 million people are there with you. It's free. No admission fee. It's never closed, no matter what pandemic comes down the pike. You can avoid travel hassles. You get to experience the natural world alone. And I think the alone part is really important, not mediated by somebody else. You're going to develop a personal relationship with Mother Nature. It'll be unique to you. And this is particularly important for our poor kids who are suffering from nature deficit disorder, according to Richard Louv. So we're trying. We get 30 kids, we put them on a bus with a teacher, and they drive for an hour to a natural area, and they walk around for an hour, and the teacher tells them not to touch anything. And they get back in the bus, and they go home. And that's their experience with the natural world, which I'm sure is better than nothing, but it's really been an experience with 30 kids and a teacher telling them not to touch anything. If they have some part of the natural world right where they live, all they have to do is go outside and become friends with it, alone, no parental supervision. They will come home again. When we hover over our kids, we're sending the message that this is dangerous stuff. That's not the message we want to send to our kids, because they are the future stewards of the planet. If they don't know that, if they're afraid of it, if they don't want to be stewards, they're going to be lousy stewards. We can't afford any more lousy stewardship. And maybe they will learn how to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii on a very modest patch of nature. It's a little piece of lawn with a hedge, but there are anole lizards there. And when she discovered that, she sent me this picture to describe how you hunt lizards. You get on the ground and you cover yourself with leaves and sticks so the lizards can't see you coming. Then you crawl very slowly toward the lizard. No smiling, this is serious business. You can wear your best dress, that's okay, but you sneak up on the lizard, you catch the lizard, you put it in an aquarium, you learn how to take care of that lizard. You learn how to be a good steward of the lizard. You fall in love with the lizard, with that part of nature. Now, I don't think Zoe's going to be crawling on the ground in her best dress, catching lizards the rest of her life. I don't think. She sent me this picture not long ago, so who knows. But I guarantee she's going to remember these experiences the rest of her life, and I guarantee it's going to help her be a good steward of the planet. If you want your kids to do more than catch lizards, get Nancy Strinisty's Nature Play at Home. Dozens of examples of how to expose kids to the natural world. And if you want to join Homegrown National Park, you can do it now. It's free. You go to our website, homegrownnationalpark.org, and you register your property on the map. What you're going to do is say, this is where I live. This is the amount of area I'm going to be a good steward of. Or I already have been a good steward. This is the amount of area of lawn I'm going to reduce. Maybe I'm going to plant a few oak trees. Maybe I'm going to put an aster in a flower pot. It all counts. And your little piece of your county is going to light up. And the object is to get your whole county to light up, then to get the whole country to light up. We want the message that everybody, and we want this message to go to the people who don't know this, everybody is responsible for good land stewardship these days. They are the future of conservation. We want that message to go viral and light up the entire map. We are asking that people reduce the area of lawn. It's not accomplishing any of the things that we need to accomplish out there. We want them to replace the lawn with the important natives that are accomplishing those ecological goals. We want people to remove the invasive plants that are already on their property. Most people, believe it or not, do have invasive ornamentals on their property. Most people don't know that. And if you have, maybe you're already protecting a natural area, maybe a little woodlot in your back or something, we want you to keep protecting that. So there are real ecological products that come from the development of homegrown national park. One will be a significant increase in biodiversity. And I can attest to that from what's happened at our house. There will be a measurable reduction in invasive species. Remember, if 85% of the land east of the Mississippi is privately owned and everybody got rid of the invasives from their private property, we would be 85% done, which would reduce the seed rain on all the other places and make the rest of the cleanup a whole lot easier. There will be a significant drawdown in atmospheric CO2. Tough to measure, but believe me, every plant you put in there is going to put more carbon in the ground and build its tissues out of carbon. And we're going to start to transform the areas outside of parks and preserves into viable habitat, which will help connect them. There are sociological products, too, and one is national awareness, not just of what the problem is, but what the solution is. Got to talk about solutions these days. We're trying to change the culture. I want people to recognize that nature's not optional, it's essential, and that we all have roles, we all have responsibilities in sustaining it. We're trying to convert hope into action. It is definitely time for action. And we're not competing with other conservation organizations because we're not charging, we're not pulling members away. So what we want to do is get all the people who belong to Audubon and National Wildlife Federation and Wild Ones and everything else to register their properties on the map. The object is to create a visual of successful conservation on private property. So we have a much better feel of how we're doing. We're doing better than most people think. So we're going to shrink the lawn. We're going to join Homegrown National Park. What plants should we replace the lawn with? I'm going to argue that at least some of them have to be what I'm calling keystone plants. Remember what a keystone is? It's a stone in the middle of the arch. If you take the keystone out of the arch collapses. Well, if you take keystone plants out of your local food web, the food web collapses because they are making most of the food. Just 14% of our native plants are making 90% of that caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s, the supports of that ecological house. We've been trying to build ecological houses out of wallpaper for the last century, and that doesn't work. You're not through building your ecological house once you've got your keystone plants, but they're an essential component. So the question is no longer simply, are native plants ecologically better than non-native plants? On average, they certainly are. But there are a lot of native species that aren't contributing all that much either. So the question really is, do we want to put the most powerful plants back there, the ones supporting the most pollinators and the most caterpillars, or not? What is supporting the most caterpillars? It's one of our oaks. That is the most productive keystone plant in 84% of the counties in which it occurs in North America. They support over 950 species of caterpillars nationwide. Where I live, 557 species. There's no other plant genus that comes close to that. So where do you find, if you say, I want to put some keystone plants in, you go to Native Plant Finder on the National Wildlife Federation website, you put in your zip code, and the ranked list of both the woody and herbaceous plant genera that are best at supporting food webs in your county will pop up. And it's going to look something like this. Oaks are going to be number one. Native cherries and willows and elms and birches are all right up there. Let's focus on the herbaceous plants over here. Goldenrods are typically up at the top. Native asters are up there. Perennial sunflowers are up there. Not only are they good at making lots of caterpillars, they're also good at supporting specialist bees. If you have those 3 genera in your yard, there's up to 44 species of bees that can be there as well. And they will not be there if you don't have those genera. So this is when we're creating pollinator gardens. You want to plant for the specialists because the generalist bees can use those plants as well. So we're going to shrink the lawn. We're going to put in keystone plants. We're going to invite a lot of insects to our yard, and then we're going to kill them with our security light, which of course is not the goal. There's a lot of research that is demonstrating that light pollution at night is one of the major causes of insect declines around the world, but certainly in the temperate zone as well. These are all the ways that lights are killing insects at night. But to me, this is good news. We have to turn around insect declines. We can't ignore it. We've already lost more than 45% of the insects that used to be here just a few years ago. If we can do that by flicking a switch, we're getting off easy because it's easy to flick a switch. There's a lot of switches to flick, but there's a lot of us to flick those switches. But I know what you're going to say. Well, I can't turn the light up over my barn or over my garage or over my front porch because the bad man will come. Okay, put a motion sensor on your light so it only turns on when the bad man does come. And the first thing you're going to recognize is the bad man doesn't come very often. And if you don't want to do that, take the white bulb out of your security light and put in a yellow bulb because yellow wavelengths are far less attractive to nocturnal insects than are white or blue wavelengths. If we did that, replaced our white bulbs with yellow bulbs overnight, we could save millions of insects. And if we use LEDs, yellow LEDs, we could save millions of dollars as well. Okay, we're going to shrink the lawn. We're going to, what else are we going to do? Put on keystone plants. We're going to modify our light system. Then we're going to hire Mosquito Joe to come kill all of our insects. This is a booming business around the country. But the mosquito foggers say it's okay because we're using a natural product, and they're using pyrethroids. That's the compound found in chrysanthemums, which evolved to kill insects. And it's industrial strength pyrethroids, but they say it's a natural product, so it's okay. Cyanide is a natural product too, so I'm not sure that's a good argument. They also say it only kills mosquitoes, and boy, I wish they were right about that. But they're not. It kills everything, including monarchs. Big monarch kills when they fly through Mosquito Joe. It kills all the pollinators that we're trying to support. And when your neighbor does it, it kills your insects too, because that fog just floats around. The interesting thing is it doesn't control mosquitoes. Yes, it kills some mosquitoes, but you've got to kill 90% of the adult mosquitoes to get control of a population. You don't even try to control mosquitoes in the adult stage. Mosquito Joe kills between 10 and 50%. That's why he has to keep coming back and keep charging you. If you really want to control mosquitoes, you do it in the larval stage and a biocontrol product using Bacillus thuringiensis called mosquito dunk is a cheap, targeted way to do it. You get a bucket, you fill it full of water, you put in a handful of straw or hay and let it ferment for a couple of days in the sun and build up populations of diatoms and algae. That is what mosquito larvae eat. Then you put in a mosquito dunk. You go to the hardware store, buy this, like $12 for a sheet of mosquito dunks. The eggs that becomes an irresistible brew to female mosquitoes who want to lay their eggs. They can't resist, so they lay their eggs in your bucket. You throw in your mosquito dunk, the eggs hatch, and they eat the little disc, and they die. So again, extremely targeted. It only kills aquatic diptera, and the only aquatic diptera in your bucket is mosquito larvae. So if a dragonfly larva gets in there, it's not going to hurt it a bit. If your dog drinks it, it's not going to hurt. You might put a coarse screen over it so your local chipmunk doesn't commit suicide, but it's targeted, it's cheap, and if everybody did it, you actually would reduce your mosquito population. But if you have to use, or you want to use your yard during peak mosquito time, get a fan. Plug it in, it creates enough directed flow, it feels really good in the hot summer, and mosquitoes can't fly into it. So that's a cheap way to enjoy your yard without killing anything. All right, fourth thing that we need to do is to landscape in a way that allows those all-important caterpillars to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, now this is just an example, but oaks support 511 species of caterpillars in my county. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, and then it does it all over again. And I wish everything did that, but most species don't. Around 94% of them finish growing as caterpillars on the tree, and then they drop from the tree, and they wiggle their way beneath the soil surface and pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree. We don't tolerate it. It's messy. And we mow and compact the soil under those trees so that it's rock hard, particularly in the summertime, and the caterpillars can't get underneath, which means we're creating ecological traps. If you plant the right plants and the moths come in and lay their eggs, and the caterpillars fall down and die, that's not the goal either. And of course, the cement landscape is not going to do it either. This is what most people do. They've got a tree in a yard. I have a new grad student this year who's starting to measure how well caterpillars do in a situation like this. But I guarantee they're going to do better in a situation like this, where you've got a layered landscape. You've got your tree, then maybe a dogwood up here, and then a native azalea and ferns and ground plantings. It's not compacted. Nobody's walking in there. Nobody's going to mow your caterpillars. This is soft landing. They fall down and they can spin a cocoon in this material, no problem. Survivorship will be much higher. This is a great place to do your fancy spring ephemeral gardening. This is how you shrink the lawn. Put big beds around every tree, and all of a sudden you got a lot less lawn. Notice I don't say get rid of lawn. I say reduce the area, because lawn is still a cue for care. We're going to mow that lawn that we have, and it's going to be really pretty. It's never going to be the place where we have a lot of biodiversity, but it can surround the places where we do have a lot of biodiversity. These are all safe sites for those caterpillars. Use your native ground covers like wild ginger, like native pachysandra, like there's Virginia creeper being a great ground cover, or golden seal, or mayapple, or foam flower, or ferns. If you can see the ground, you don't have the right mulch, because you want green mulch. The trees will love it, and it's a lot less weeding, by the way, once it's established, and it's all great safe sites for those caterpillars. How do you create those beds when you have a lot of lawn? Somebody sent me this picture not long ago. In the fall, you rake the leaves where you want it, and pile them up there. Let them really smother that lawn, and then plant right through it in the spring. It's a great way to reduce the area of lawn. Okay, another grad student, Desiree Durango, did some great work with chickadees in the suburbs of Washington, D.C., and her results suggest that there is room for compromise in our plant choices, and that's good news. Compromise is actually a good thing, despite what you've heard. She had one simple question. How well do native landscapes support chickadee populations over time compared to landscapes dominated by non-native plants, non-native ornamentals? And the first thing she found is when those landscapes, the ones that are dominated by non-natives, if you count the caterpillars, there's 75% fewer caterpillars in those landscapes. So right away, you reduce the amount of bird food by 75%. They were 60% less likely to have breeding chickadees at all. So there were nest boxes up in everybody's yard, but the chickadees would come and look around and say, there's not enough food here. We're not even going to try to reproduce. If they did try to reproduce, they laid 1.5 fewer eggs. Those clutches were 29% less likely to survive at all. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. If you throw all that together into a population model, based on the percentage of non-native woody plant biomass in your yard, from none to 100%, this is what you get. We focused on woody plant biomass because that's where chickadees forage, on woody plants. The dotted line is replacement rate. That is the rate at which the population has to make babies to replace the adults that die every year. Chickadees don't live that long. And if you breed at this rate, if your population produces that many babies, it's a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, over here where there's very few non-natives, you have a growing population. But if you make, if you're down here where you've got a lot of non-natives, you make fewer babies than adults die, you've got a shrinking, unsustainable population. Right here is where those lines intersect, liberally speaking. So you can have up to 30% of your landscape, your woody plant biomass, non-native, without destroying your local food web. That's the area of compromise I'm talking about. Now, we can't tolerate any invasive plants because they're ecological tumors. They just keep growing and growing and growing, and then they escape and castrate our local ecosystems. But there are a lot of ornamental plants that are not invasive. Remember Dan Getman? Anybody notice that that's a ginkgo tree? What is a ginkgo doing in his native planting here? Well, Dan's wife likes ginkgos, and she said, please plant a ginkgo. So Dan did. Is that plant destroying the functionality of that landscape? No. Is it going to escape and wreck the local woodlot? No. It's just there. So what are plants that are just, I like to think of them as statues. So there's Dan's, if everything was a statue, it wouldn't be very productive. So it's not the presence of non-native plants that destroys food webs. It's the absence of the productive plants that are not contributing energy to the food webs. If we increase those productive plants, those contributors, we can tolerate a lot of these. Can we use native plants in formal designs? Of course we can. This is a Lynn O'Shaughnessy design, taken from a drone 400 feet up. Every plant, I mean, you don't get more formal than that, but every plant in that landscape is a native plant. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe all the time. And I guess that's okay because they're non-native plants over there. Can we get a pollinator garden into a suburban yard like this without offending anybody? Sure, just put a fence around it. It formalizes it. It tells your neighbor this is not just a bunch of weeds you forgot to mow. It's pretty when it's in bloom. It's satisfying the needs of several species of bees. It's not very big. Could be bigger, but if everybody did it, it would help. Help what? Help produce those pollinators you hear so much about. Why do we need pollinators? Well, it's a third of the crops depend on pollinators. Mae Berenbaum, University of Illinois, actually looked at that figure. She doesn't know where it came from. It's really about a 12th of our crops depend on pollinators. And I don't like that argument because people say, I don't live next to a farm, so I don't need any pollinators. Forget the agriculture argument. We need pollinators, and we need them everywhere because they pollinate 80% of all plants and 90% of all flowering plants. So where do we need pollinators? Everywhere we need plants, which is everywhere. How about this? A Drew Latham design, much bigger. Imagine the amount of life that is here versus the amount of life that is here. Seems like a no-brainer. Can municipalities help us live with nature? Yes, they can, and more of them are doing it. Minnesota's been doing it for quite a while. It's got a cost-sharing program that encourages homeowners to reduce or replace their lawn with appropriate Minnesota prairie plants, very popular. Pennsylvania's got a young but very similar program. There's an island off of Florida where they're paying residents to allow burrowing owls, listed species, to burrow in the front yard. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. If you've got an endangered species on your property, we're going to pay you to be a good steward of that species. Everybody would want an endangered species. Put a bounty on these invasive ornamentals like calorie pear. That's what St. Louis, Missouri did, Fayetteville, Arkansas. North Carolina's got a bounty on them. South Carolina's banned them altogether. That can work. Public utilities are starting to give people $100 coupons to plant water-efficient native plants in areas where there's not enough water. And of course, the big lawn reduction programs, particularly in California, this has gone up. You now get $3 per square foot rebate for every square foot of lawn you replace with xeric plantings. It's working. It really is working. And if you want more information on each one of those programs, memorize that. All right, I think we've made 3 missteps in the early years of conservation, and this one's important. We're starting to think of nature as if it's optional. It's fun. We like to visit it. We enjoy it somewhat, but it's optional. And if it's not essential, when push comes to shove, when resources are in limited supply, which is always, then nature will take a back seat. I went to the Cincinnati Zoo before the virus broke out, and there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We want to save nature, we want to save wildlife so that future generations can enjoy it. That was Teddy Roosevelt's argument for supporting the national park system. These are wonderful places, we want to save them so that future generations can enjoy them. Well, I get that because nature is enormously entertaining, but it's much more than that. We need to save nature so that we have future generations. A little bit more urgent. We've also assumed that humans and nature cannot coexist, and we talked about that. But if we restrict conservation just to the areas where there's not a lot of humans, we're going to fail because those areas are too small and too isolated. David Quammen has a wonderful analogy between a Persian rug and an ecosystem. That is a functional Persian rug. That's not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug, and that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I don't like that language, I don't like that reasoning, because it suggests they're places on planet Earth with no ecological significance. Not so. Every square inch of the planet has ecological significance, including our yards, including our corporate landscapes, including our roadsides, even including much of our agriculture. So we need to glue our rug back together again, folks. We've got to put the plants back. Not just to make biological corridors between viable habitats, but to recreate viable habitats in all the areas we removed them. This is starting to happen. And 10 years ago, I couldn't have said that with much confidence, but it really is starting to happen. And when it does happen, it'll be the first time in modern history that humans have coexisted with nature. Our third misstep was to leave Earth stewardship to just a few specialists, a few conservation biologists, a few ecologists. For some reason, we didn't see it as an inherent responsibility of everybody on the planet. But I don't know why, because every single person on the planet requires healthy ecosystems. So why wouldn't everybody share the responsibilities of keeping those ecosystems healthy? Stan Rushworth, a Cherokee elder, once said that the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You are not born with those mindsets, you're taught them. We're very good at teaching this one. We have been terrible about teaching our kids and our peers that we all have obligations to good earth stewardship. That doesn't mean you have to save biodiversity for a living, but you can save it where you live, and if you do, it empowers you. More and more people these days are recognizing that the earth is in trouble. The earth has a lot of problems, but they all feel powerless. What can one person do? Well, one person can shrink the lawn, one person can modify their light system, one person can use keystone plants, one person can remove the invasives from their property. We didn't even talk much about that. One person can shrink the lawn. There's all kinds of things that one person can do to totally turn around the functionality of their little landscape. And it shrinks the problem down to something manageable. Don't think about the entire planet's problems. You get depressed. Just worry about the piece of the planet that you can influence. If you own property, it's obvious. That's where you start. If you don't own property, help somebody who does. Help a land conservancy, help a park or preserve, help a campus. They're all underfunded, they're all understaffed, they will love you as a volunteer. So as a property owner or a volunteer, each one of us has the power, and we actually have the responsibility to turn dead landscapes like this around. Whether or not we decide to do so is going to determine nature's fate, and then ultimately our own. So I think I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. Thanks a lot. Thank you very much. Thank you. All right, you can sit down. I know that's a long talk, and I know a lot of you have got to go home and do busy lives, but if anybody wants to stay and do questions, we will do it.
Who's got a question for Professor Tallamy? Oh, that one's yours, Amanda.
If you could go back to the slide that had all of the...
The one you have to memorize?
Good.
That'll be the much easier way to do that. Yeah.
Is that okay?
Yeah.
I had a question as well. You talked a lot about... I'm here. Sorry, I just took the mic right away from her. You talked a lot about getting rid of invasive species in our area, but not a whole lot about how do we identify what those are. I suppose we can Google it, but do you have any suggestions?
Everybody knew what the endangered species
Well, I know the pears are, but the invasive species. Yeah.
Okay. Yes, Google it. There are a number of the Google is a wonderful source of information. If you say invasive species of Indiana or invasive species of your town, whatever, there'll be a list there with pictures. So that's the best way to do it. If you are wondering what a plant is in your yard, take a picture of it and put it. There's an app associated with iNaturalist called Seek, and it's very good. It'll tell you what it is, or you post it, and somebody will tell you immediately what it is. There aren't that many species of serious invasives, so you can learn them in an afternoon. I almost said something snarky, but I'm not going to say it. Go ahead. Go to your local nursery and see what they're selling. It's going to be
Thank you. I just wanted to help with that question. If you do want to know locally what we have, non-native invasives, we have our local soil and water conservation districts who can help you out with that information. Our local Purdue Extension, and we are gathering local community members that are working on a group called a SISMA, which I can't exactly remember. You'll learn there's a lot of acronyms.
Yeah.
But we're working to get rid of our non-native invasives and replace those with natives. So.
By the way, there are still a number of serious invasives sold in the nursery trade, and they're sold because they're not banned statewide. A lot of states are banning them, so what you need to do is convince your state legislature that this is a serious issue. Some nurserymen say, hey, we'll go out of business if we can't sell calorie pear. That's utter nonsense. It's just not true. So consult other states that have done it. More and more states are doing it. It's definitely the future, and the sooner you get these things banned, the better.
As we plant the oak and the other species you're talking about, how do you prevent the deer from eating it?
We had a meeting this morning talking about all these impossible issues. Yeah, deer are a huge problem in and of themselves, and they're directly linked to the invasive species problem. The reason many of these species are able to invade our natural areas and replace the natives is because the deer eat all the natives. That's a disturbance that creates an open niche. When the baby oak tree comes up, the deer eats it. It doesn't touch the burning bush. So of course you have only burning bush. So invasive species control is tightly linked with deer control. Control, not elimination, but they are 10, 13, 14 times over the carrying capacity, over the ability of the environment to sustain them indefinitely without hurting everything else. So the only responsible thing to do in terms of management is to get that population back down. Could do that a couple ways. We can bring back the predators, bring back the mountain lions and the wolves. We can stop shooting the predators that you do have, like coyotes, or we can control them ourselves. Right now, the biggest deer control is your car, and insurance companies don't like that. It's serious. 1,000 people a year are killed by deer collisions with cars, which is far more than any other things we worry about. So, and they have created the Lyme disease issue by increasing the deer tick populations. So there's a lot of good reasons to control deer. We know how to do it. The reason we don't do it, it's a sociological issue. It's because many of us say, no, don't shoot Bambi. And I understand that. Bambi's very, very cute. But we've created, there is no population that can grow forever without serious consequences. And if you remove the top-down controls, that's what they do. These are ecological laws. We can't argue our way out of it. So.
I watched a video that you posted on the internet, and I remember you saying, if you can't do anything else, you could do one thing, and that was to plant an oak tree. Would you tell us about that?
Yeah, that's a different talk. But well, it's just because oaks are those really important keystone plants. There are four things that every landscape, four ecological responsibilities of every landscape. Manage the watershed, sequester carbon as much as possible, support pollinators, and support the food web. Oaks do all 4 of those, and they do 3 of them better than any other plant. They're sequestering more carbon, they're managing the watershed with their huge root systems better. They are supporting the food web by adding all those caterpillars and everything else I didn't talk about to the food web. And even though they're wind pollinated, they also support pollinators. You watch those oak catkins in the spring, and spring bees go to them all the time. They're not moving the pollen to the female flowers. That's what pollination is, but they are using the pollen. So they're just doing all the things we need them to do. That's why I like oaks. Yeah. I thought you were going to say that if you can do one thing, vote. Because, you know, there's 80% of us live in cities. Our ability to manipulate landscapes is more and more limited. So we need to vote for the people who recognize that these are serious issues. And we all can do that.
Dr. Tallamy, first of all, I want to thank you. We appreciate your work around our house, and welcome to Indiana, by the way.
Thank you.
2 questions. One, would you be willing to trade any seeds for those American elm that are growing in your yard? And 2, I'm wondering if you have any thoughts around the GM chestnut trees. We're real interested in chestnuts around our house. I am personally, and I'm just wondering if you got any thoughts on that.
Yes, I do. So American chestnut got the chestnut blight. We invented mail order catalog plant mailings that year. We brought Japanese chestnuts over that had chestnut blight. They didn't express any symptoms. And then we mailed them up and down the coast and infected all the populations of American chestnut very quickly. Deadly disease, took them out. Of course, there are rootstocks in the ground, but they ecologically eliminated that very important plant from our forests. So the big efforts from the American Chestnut Foundation to put those plants back, but they're not going to survive unless they have a resistant gene, a gene that's resistant to the chestnut blight. So they've tried for a long time now through back crosses to get the resistant genes from Chinese chestnut into the American chestnut. And they had some success, but they're in the 12th back cross, and then there's some other diseases that are being problematic. So they're now looking at genetic engineering to take, there's a gene in wheat, I think it is, which is resistant to the chestnut blight, and put it into American chestnut. And of course, some people across the board say, I don't want any genetic engineering. But you know, over the thousands of years of breeding, plant breeding that we humans have depended on, that is genetic engineering. This just does it quickly. If you're worried about resistance to chestnut blight spreading to other trees, I mean, that's not going to happen. American elm doesn't breed or chestnut doesn't breed with any other trees. So I'm all for it. I think the benefits far exceed any of the risks, and they know that it works now. The process is in getting it approved. So,
Dean Redding is going to get the last question of the evening.
Thanks. I maybe a little tangential to your focus on individual efforts here, but your comment about voting prompted me to recall, you know, when I was younger and autumn olive was the answer to everything, and then later calorie pear. And are you finding, as you look into this, are state and federal governments starting to catch up to this issue, and are they becoming more and more aware of the need to plant native species?
you know, way back in the Clinton era, you had the National Invasive Species Council. I sat on it for 3 years and realized how these governmental agencies work. It was populated with everybody who has a stake in whether or not we did anything about the problem. So there was many people on the panel there specifically to make sure we did not do anything as the people who wanted to do something. So I didn't have time for that. But yes, they're aware of the problem. We just banned in Delaware the sale of invasive plants. And that came about because of Senator Stephanie Hanson's, who said, we need to do this. But she did it really well. She took her time. It took 2 years. She invited all the the stakeholders, including members from both sides of the aisle that had to vote on this, and had a number of meetings. I came and talked to them, and in the end, she got 100% approval from both sides of the aisle, which to do that on any issue these days is pretty good. So it was because she was listening to all sides, and because they sat there and listened to the nursery, and most of the nurserymen said, yes, we should ban them so that there aren't any cheaters. If you do voluntary, I'm not going to sell this voluntarily, the guy down the street sells it, the public just doesn't know. They want, oh, it's a pretty plant, I'm going to buy it. So it has to be at some level of top-down control. It's not going to reduce the amount of sales. I'm talking about getting more plants in the landscape. And if we do that, that's going to help the nursery industry. I don't think there's any kickback from China to be selling calorie pear. It's just, it's crazy. So I'm sure that's the direction we're going. A number of states have done it. So yes, they do know what the problem is. But there's pushback from some members of the horticulture trade.
Well, let's thank Dr. Tallamy for a very inspiring lecture.